All right, so let me find my pink marker. Where'd my pink marker go? Where has it gone? Wow, it's a pretty small room. Doesn't really have too far it can go. There it is. Boom. Okay, I'm gonna hold off one more video to do the example. This is video 13, 7. I'm going to hold off doing the example because I want to summarize the results, okay, and be careful about doing it. And I think that's worth devoting a video to. So what we came up with for this case here, and we'll come back to this in just a minute, is 2nt is equal to m lambda. That's for an m is equal to 1, 2, 3, ... That's for destructive interference. If those conditions hold, where m is an integer, a counting number, then we get destructive interference. For constructive interference, 2nt, boy, this pink marker is bright, but man, it makes some racket. M plus 1/2 lambda, now where m is 0, 1, 2, etc. Now these are the results we derived, and they are correct so long, listen closely, as there is a single phase shift in the problem. So this applies for a single, actually write it this way. This applies all this mess here applies for one phase shift, as we have here. Remember, there's a reflection off the front of the soap film at A. Because N for the soap film is larger than N of the air, we have a phase shift. But the second reflection back on the back side of the soap film, there is no phase shift. So we derived this case, these conditions here, using this example. And in this example, there is only one phase shift. But we could have 0, 1, or 2 phase shifts. I'm going to work this example in a minute with 1, then I'll work an example with 2, and you can see what I'm talking about. But I want to quote the result right here. These conditions are flipped and by that I mean the destructive interference becomes constructive, that first formula, and the constructive interference becomes destructive interference, the second formula. Okay. This is for 0 or 2. Because we have 2 points of reflection, A and B. Listen closely. We have 2 points of reflection, A and B. There are 3 possibilities. Okay. We can have 0 phase shifts. We can have 1 phase shift, as is the case here. Or we could have 2. In other words, between the points A and B, maybe neither one of them has a phase shift. Maybe one of them does. That's the case we've covered. Or maybe both of them do. In the first and last cases, 0 or 2, you have to flip the destructive and constructive labels here. But if there's a single phase shift, this result works. Next up, we're going to work an example using these conditions. And then I'll show you an example where we have 2 phase shifts and you have to flip them. What was constructive will become destructive, and what was destructive will become constructive. So we have that to look forward to. Tune in to video 14, Thin Film Interference 8, coming up next.